All right, guys. I said I would do a Zoom today, and here I am. I'm here to just kind of go over questions on the study guide. I have not gotten any questions from you guys, but I also haven't made the key yet. So I just thought I'd just make the key and talk through it. I wanted to start with the second set. I'll go back to the word problems and kind of breeze through those in a little bit, but I just kind of want to remind you, the first part of your test is no calculator, no unit circle, but you have to know it. So I want to impress upon you, if you haven't taken time to kind of memorize it, please do so. I also want you to kind of see the difference between these problems. So the problems with the negative ones, those inverses are where the angle is my answer. So and I'll even kind of highlight these in blue, all of these that are the inverse ones, my answer is going to be an angle. There's some of them that are composite. I'll actually kind of do those in a different color, make those pink, that you have to do kind of two different pieces to it. Those are the same type of problem where you have to do both parts, but the ones that are normal sine, normal cosine, normal tangent, etc., those are just a ratio is your answer. So I'm kind of trying to make a little bit of a key right here on different ways to do it. I'm having you switch back and forth a lot because I need you to get comfortable with it. Oh, I've got a couple down here that I need to have a different color. Okay. The blue was just the normal inverse. So these are all normal inverse, and I've got a couple composites right here. Okay. So we'll start with the ones that we have been doing a lot of, the ones where it's just I give you an angle and you have to tell me what the answer is. Truthfully, when I go through this, my thought is it an X or Y? So sine is a Y, and sine at pi is going to be your Y at pi is the point -1, 0. So my sine there is just 0. Secant at pi, I'm still thinking about the same answer, but secant is 1 over x because it goes with cosine. So my x here is -1. So that's like 1 over -1, which is just -1. The cosecant, secants, tangents, cotangents make you think a little bit more, but they're very similar. Cosecant, that is 1 over y. And 7 pi over 6 is a 30-degree angle. And my 30-degree angle goes √3 over 2, comma 1/2. So I'm looking for 1 over that y, 1 over the 1/2. My only question before I actually do that is it going to be positive or negative? This is going to be in the third quadrant, so that will make it negative. So 1 times -2 over 1. So this answer is -2. If you're not understanding why I know this, why I know what quadrant this is in, why I know it's a 30-degree angle, truly it's just the unit circle. So you need to go to the unit circle, start finding some patterns, some shortcuts. I went over a few of them in class the other day, so maybe you can go back to one of the videos when I kind of talked through it. All right, secant is 1 over x because it goes with cosine, and 5 pi over 3 is a 60-degree angle, and that's the opposite of my 30-degree angle. So that's going to be 1/2, comma √3 over 2. And so I want to do 1 over 1/2. It's kind of almost the exact same thing as what I was just doing. Now I have to ask myself, is it positive or negative? 5 pi over 3 is in the fourth quadrant, so that's positive. So I've got, essentially, I can do the math I did up here, but I don't want to. So I'm just going to keep my answer at 2. Okay. Just because my brain's kind of fresh here, I'm going to kind of skip through to find the other ones like it. So cotangent x over y with 90, this is the same thing as 90, and we know that that point is 0, comma 1. So I go 0 over 1. We remember that's 0. Remember 1 over 0 is the undefined one. Cotangent of 11 pi over 6, I know cotangent is still x over y. 11 pi over 6 is a 30-degree angle in the fourth quadrant, and 30 is √3 over 2, comma 1/2. So I'm going to do √3 over 2 over 1/2. In the third quadrant, or sorry, in the fourth quadrant, my x will be positive, but my y will be negative. So I'm going to think of this as √3 over 2 times -2 over 1. My 2's cancel. I still have that negative, and then I'm left with just √3. Negative √3 is my final answer there. And then cosine of 3 pi over 2. I know cosine is x, and 3 pi over 2 is 270, which is the point 0, -1. And so my x there is just 0. You don't need any of this work that I'm doing, but I'm just trying to explain to you my thought process. Okay, I'm going to keep rolling. I've got 4 more just like these. All right, tangent is y over x. 4 pi over 3 is a 60-degree angle, which we know is 1/2 root 3 over 2. So I'm going to do root 3 over 2 divided by 1/2. 4 pi over 3 is in the third quadrant, which would mean both of those are negative, which means my whole answer will be positive. And even though we just did it, I'll do this again. I'll multiply it through, but the difference is negative times a negative will lead to a positive. So positive root 3. Cosine of pi over 4, cosine is x, pi over 4 is 45 degrees, and our sine and cosine are x and y of 45 degrees is always root 2 over 2. And I'm in the first quadrant because that's where pi over 4 is. Okay, next 2. Cosine is still x. Oh, I'm still doing a 45-degree angle, so it's still root 2 over 2. My question, though, is it positive or negative? I'm in the second quadrant. That's going to be negative. And actually, I didn't do this yet, and maybe I should go do it at the top of the paper. But one thing I would do is write all students take calculus, and that does help you know where things are positive, where things are negative. Okay, cosecant is 1 over y because it goes with sine. 2 pi over 3 is a 60-degree angle, and 60 is 1/2 comma root 3 over 2. It's a funky one. And so 1 over y, 1 over root 3 over 2. In quadrant 2, that's positive, so I'm good where I'm at. So 1 times 2 over root 3 is 2 over root 3, and then you can multiply by root 3 on top and bottom, and I get 2 root 3 over 3. Okay, those are all the ones that are just like the ones that we've been doing in class, okay? Now we're going to go backwards. So all of these blue answers are going to be angles. They're not going to be like they're not going to be zeros, ones, twos, 1/2s, root 3s over 2s. These are going to be angles. So in my head, I'm asking myself, okay, what angle has a cosine or an x of 0? Well, the angle that has an x of 0 is going to be 90 degrees. If you remember, we did our inverse functions. Our inverse function for sine is always in quadrant 1 or quadrant 4. Inverse of cosine is quadrant 1 or quadrant 2, and then inverse of tangent is quadrant 1 or quadrant 4. So that's kind of what I'm thinking as I'm doing this. There's another angle that has a cosine of 0, but when I'm only doing the inverses, I don't need to look there. I'm only looking in these first 2 quadrants, or these quadrants 1 and 4 or 1 and 2. Also, you can write your answer as pi or as as a radian or degree. So let me work on that. So it's 90 degrees or pi over 2. I will accept either answer as long as it's the correct one. All right. Tangent. What angle has a tangent of root 3? Tangent is y over x. And in order to get a tangent of root 3, we've talked about this several times in class, the y needs to be the root 3 over 2. The y needs to be the root 3 over 2. So the point that has the x that's 1/2 and the y that's root 3 over 2 is a 60-degree angle. So tan of 60 is root 3. So my answer here is 60 degrees or pi over 3. Okay. Inverse sine of negative root 2 over 2. So what angle has a sine or a y of negative root 2 over 2? I know negative root 2 over 2 goes with 45, but I'm not going to be in quadrant 1. I'm going to be in quadrant 4 because it's negative. So you can do 360 minus 45, which is 315. And then I know that that's 7 pi over 4 as a radian. And then tangent, this is another one that's going to be a 45 degrees because in order for tan or y over x to be 1, it needs to be the same x and y. So it needs to be root 2 over 2, root 2 over 2. So that's going to be 45 degrees or pi over 4. Again, if you're not understanding how I'm doing this, you got to do a nice good look at your unit circle. And don't be afraid if you need to draw your unit circle, like go ahead and draw one right there. But then you got to make sure that you know how to use it and you can draw it fast enough and use it fast enough because you have a class period to do a whole test. All right, I'm going to keep moving. My sine is y. Y is root 3 over 2 for a 60-degree angle. or pi over 3. This kind of matches with number 11 because that's a x, that's 1/2. Well, the x is 1/2 and the y is √3 over 2. That's the same angle. These are the same thing. So this is also 60 or pi over 3. Cosine, inverse cosine of negative √2 over 2. This is another one where it's a 45-degree angle. We know that. And because we know the only time we have √2 over 2 is a 45-degree angle, but it's negative. And if you remember with what we wrote at the beginning, is negative cosines or inverse cosines are in quad 1 or in quad 2. So I'm not going to do 360 minus that 45 like I did up here for my inverse sine. I'm going to do 180 minus my 45 to get my angle down here, which I believe is it's embarrassing. I can't think of it fast enough. 135. Don't be embarrassed if you have to do this too. Yep, 135. I couldn't remember it. All right, 135 degrees or 3 pi over 4. Okay. We'll do the other column. Oh, there's only 2 over here that are like it. Inverse cosine of √3 over 2. So that means my x value is √3 over 2. That is going to be a 30-degree angle, but I want it negative, so it's in the second quadrant. So 180 minus 30 is going to be 150 or 5 pi over 6. And then sine is 1. Well, we know sine is y, and the only place where sine or your y is 1 is at 90 degrees or at pi over 2. Okay, let's go do, I've got 2 more sections like that, so I'll keep rolling. Inverse cosine or x is √3 over 2. That is a 30-degree angle or pi over 6. Inverse tangent of negative √3. I've already done this, so I may go, I think I already did it up here. When tangent is √3, it's a 60-degree angle. Honestly, that might be something I just remember. Truthfully, if memorizing is helpful to me, I'm going to remember that. That's a 60-degree angle, but I want it negative, which means it's in quadrant 4. So that's the angle 300 or 5 pi over 3. All right. Sine or y is √3 over 2. That is a 60-degree angle or pi over 3. And then inverse sine of √2 over 2. So that's a 45-degree angle or pi over 4. See how by just doing a lot of these, you start seeing patterns, you start recognizing things. So if anything, I would sit and do these. Okay, let's do this again. We've already done inverse tangent is √3. That is 60 degrees or pi over 3. Ooh, but the one underneath it, we haven't done yet. However, I think I can do it easily without any work. Inverse tangent is √3 over 3. In inverse tangent is √3, my y is that √3 over 2. Now, in order to have to rationalize that, that would mean my x is that √3 over 2. So now I don't want the 60-degree angle. I want the one that's just like it, which is the 30-degree angle, since they share the same points, just in opposite orders. So this is 30 or pi over 6. And truly, this is how I remember it. √3 and pi over 3 go together. And then 3 plus 3 is 6 and pi over 6. Don't know if that's helpful, but that's helped me in the past. Okay. Y is √2 over 2. That's 45 degrees or pi over 4. And cosine or x is √3 over 2. That is a 30-degree or pi over 6 angle. Okay. All right, the last ones that we haven't done, these pink ones are composition. It's a composite, it's a group effort, you have to do the inside part first, and then we can do the outside. So like these first two, I gave you the angle, and now we want to do cosecant of that angle. Once I find that answer, I'm going to do inverse sine of that part, okay? So cosecant is 1 over y. My point of pi over 2, that's a 90 degree, and its coordinate point is 0, 1. So my cosecant is going to be 1 over 1. So I'm thinking about doing inverse sine of 1. This whole parentheses, cosecant of pi over 2, just breaks down to just 1. Now, though, I'm not done, because now I want to do inverse sine of 1. So I'm asking myself, where is my y1? Oh, this just happens to be the exact same angle. It's going to be pi over 2 or 90 degrees. All right, we're going to do a similar idea for the next one. It says cotangent of root 3 over 4. Well, I know root 3 over 4 is a 45-degree angle, so its point is root 2 over 2, root 2 over 2. And cotangent is x over y. This is root 3, or 3 pi over 4 is in the second quadrant, which would make my x negative. So when I do this, I'm going to do negative root 2 over 2 divided by root 2 over 2. I'm going to be honest, I've done this enough times, and I would hope you guys have at this point too. I know that's just going to simplify down to negative 1. Don't forget your negative with it. So now I'm thinking, what's my inverse sine of negative 1? What's my angle that has a sine or a y of negative 1? Well, that is going to be 270 or 3 pi over 2. Notice on both of these, I had to do the inside first. I did my cosecant of pi over 2 and got 1. And I did my cotangent of 3 pi over 4 and got negative 1. And then I had to take that number I found and then do the outside function, the inverse sine of that. I'm going to do a very similar thing over here, but this time I'm going in a different direction. I'm doing my inverse sine first. So I'm going to do my inverse sine of root 3 over 2. So I'm asking myself, what angle has a y or a sine of root 3 over 2? Well, that's going to be a 60-degree angle. So then I'm going to do cosine of 60. And we know cosine or x at 60 is 1/2. So my answer there is 1/2. The funny thing is, if I give you a fraction or a ratio, you're going to give me a fraction or a ratio back. And if I gave you an angle, you're going to give me an angle back. So you have to kind of do the in-between step in order to give me what we need to do. Okay. We've got a few more of these. Let's keep moving. I've got 8 more. So we're going to finish up with these guys. Okay. So a tangent of negative pi over 4, that's just the 45-degree angle in the 4th quadrant. That is the same thing as 315. And so inverse tangent of any 45-degree angle is going to be 1. But since I'm in the first quadrant, tangent will be negative. So tangent of negative pi over 4 is the same thing as negative 1, and then inverse cosine of that. What angle has an x of negative 1, and that is pi or 180. Okay, cotangent is x over y of pi over 6, which is a 30-degree angle, which has the coordinate point root 3 over 2, comma 1/2. So I'm going to do that. I'm going to do root 3 over 2 divided by 1/2. I've done this enough to know I'm going to end with root 3, but I'll just do it out for you. Root 3 over 2 times 2 over 1. I get root 3. And so now I'm going to do inverse tangent of root 3. We've done this a couple of times. I know that it's going to be pi over 3, if you remember my little trick, or 60 degrees. The other thing I do is I remember that my y must be root 3 over 2 in order to end with no fraction. And so only 60 or pi over 3 has a y. That's root 3 over 2. Okay. 2 more over here, cotangent. Cotangent of 5 pi over 6 is going to be just like cotangent of pi over 6, because it's still x over y. It's still the same 30-degree bow tie angle. It's still root 3 over 2, comma 1/2. The only difference is it won't be positive root 3, it's going to be negative root 3 because it's in the second quadrant, and my x would be negative and my y wouldn't be. So that's going to equal negative root 3. So when I do inverse tan of negative root 3, which again is just like the one we just did, we did positive and got it was pi over 3 or 60. If I do negative, I'm going to minus 60 from 360 and get 300. And that in radians is 5 pi over 3. All right. Cotangent. We'll keep using the same one. So again, I gave you a million problems like this because I want you to see the patterns and be like, oh, I keep doing the same problem. I want to see that. So we've just done inverse tangent of root 3. We've done that several times. I know that's 60. So I want to do cotangent of 60. I remember that my coordinate point for 60 is going to be 1/2 comma root 3 over 2. And so cotangent x over y is going to be 1/2 divided by root 3 over 2. Don't forget to rationalize. So I get root 3 over 3. Oh, I was so excited about my color coordinating and then I screwed it up on all these pink ones. I'll do this. Those should be pink, and then these should be pink too. It's my bad. Okay. All right, I got 4 more like this. All right, cosine of pi over 4, I'll just finish these last ones in pink just because I'm not consistent, is a 45 degree. My x at 45 we know is root 2 over 2. And so when I do inverse sine of root 2 over 2, I'm asking myself what angle has a y of root 2 over 2? Well, that's funny. That's the exact same angle. It's 45 or pi over 4. All right, next one, I've got cosine of 5 pi over 6. That is a 30 degree angle, and my x at 30 is root 3 over 2. So now I'm going to do my inverse sine of root 3 over 2. That is very similar to, or that is my y, and my y is root 3 over 2 at 60. So 60 degrees or pi over 3. Cosecant of negative pi over 2, that is 270 or 3 pi over 2. And cosecant is 1 over y. We know the point at 270 is 0 comma negative 1. So 1 over negative 1 is just negative 1. So inverse cosine of negative 1, what angle has my x? That's negative 1. That's going to be pi or 180. And then last problem. So now I'm doing it backwards. I'm doing the cosecant first. I'm doing inverse cosecant of 1/2. So what angle has a cosecant or an x of 1/2? That's going to be 60. So now I want to do tan of 60. We know tan is y over x, and we know that the point at 60 is going to be 1/2 comma root 3 over 2. So root 3 over 2 divided by 1/2 or times 2 is just going to be root 3. Okay. There's somewhere between 10 and 20 problems like this on the no calculator sheet of all of those different types. So those are all good to practice and do on your own. The other thing on the no calculator sheet is this first part of the front page that I maybe should have started with, but I didn't want to. Is it a sinusoid? It's sinusoid if the periods are the same. And that's all that matters. Are the periods the same? If yes, they're sinusoid. If no, not sinusoid. Remember, we look for the periods at the number in front of x. So whatever number is right here, that helps me know what the period. These numbers help me decide the period. And the period you find by doing 2 pi divided by that number b. So 2 pi divided by 1, 2 pi divided by 1. That's going to be the same number. So letter A is yes. Letter B, I'm going to do 2 pi divided by 2. and 2 pi divided by 4. Even though those aren't simple, I know that they're not the same. Pi and pi over 2 are not the same, so that's a no. And then 2 pi divided by 1/2, there's no way that's going to be the same thing as 2 pi divided by 2/5. So that's also a no. Okay, gonna jump over, do the other two really quick. Even though this is 7 pi and this is 7 pi, it's at least the same number. So 2 pi divided by 7 pi will be the same thing as 2 pi divided by 7 pi. So yes. 2 and 2, okay, 2 pi divided by 2 will be the same thing as 2 pi divided by 2. And then last, these both just have 1 in front, so it's like 2 pi over 1, so they will be the same as well. Okay. There's one thing I want to add in. That is all no calculator stuff. So is it a sinusoid? And then the whole back 2 pages. On the calculator part, is all these word problems. One other thing that will be on the no calculator part that I didn't specifically put on here, but we've done in our homework and you've done on your notes. If you go back to 4.7, number 3 on your homework, this is fair game for your test. These types of problems are on the test. Yes, on test. Okay. I would go back to your homework and redo those or relook at those. And I would go back to your notes and look at those too. I'm not going to specifically do any of these today because I'm going to go try and do the word problems in my last like 20 minutes or so of this. But I want you, if you have questions, ask me on Monday in office hours or look at these homework questions. They're really not that hard. And it's actually a lot like what was on the last test. But I don't want to blindside you. This will be on the test. Okay, let me go back to the study guide. Okay. Okay. There's some easier word problems. There's some harder word problems. I'm going to just I'll try and just kind of skate through the easy ones and then spend a little time on the harder ones in a moment. So we are doing this. This is all SOHCAHTOA. I'll write it one time, and if you need to keep writing it, do it, but it's all SOHCAHTOA. A bird in the top of the tree is looking down at the worm on the ground. Okay, as I label my triangle, I've got a bird in the top of the tree. There's a worm. That's the tree. His angle of depression is 18 degrees and 12 minutes. That's going to go both up here and down here. Find the height of the tree if the worm is 123 feet from the base. So 123 goes on the bottom, X goes along the vertical, and I'm going to find that angle really quick by doing 12 minutes divided by 60 to get that into degrees. Get my calculator up for this last part of today. 12 divided by 60 is 0.2. So 0.2. So this angle is 18.2. I now know that I can label opposite, hypotenuse, adjacent. And based on what's given to me, I'm going to do angle, opposite, adjacent. So I'm going to do tangent. Remember, we do tangent a lot. So don't get panicked if you're like, why have I done tangent 17 times? We just do a lot of tangents here. Tan of 18.2 equals X over 123. Super simple, multiply by 123 on both sides. And I'm going to plug 123 tan 18.2 into the calculator. Make sure you are in degrees because I gave you 18.2 as a degree. 123 tan 18.2, and that is 40.4. I will try and give you directions on the test on how to round. When in doubt, I do at least one. And I am going to put feet in there because that's what it is. That's how tall my tree is. Okay, let's go to number 3. All right, find the angle of depression of an airplane that is 2,000 feet above ground, 2,000 feet, and needs to land at an airport that is 2 miles from the airplane. So the airplane is up here and the airport is down there, and this is just the ground. So the 2 miles is going to go here. I'm going to argue that's true. And then my angle of depression is the same thing of my angle as same thing as my angle of elevation. The only hard thing here is you need to convert your feet and your miles to be the same. I'm going to make my miles be in feet. So I'm going to think about 2 miles. 1 mile is the same thing as 5,280 feet. So I'm going to do 5,280 times 2, and that's going to be 10,560. So that's what I'm going to use for this problem. All right, then I label opposite, adjacent, hypotenuse. I'm going to find my angle using my opposite and my hypotenuse. So that means I'm going to do sine of theta or sine of x, I don't care what you call it, equals 2,000 over 10,560. In order to solve that, you're going to do your second sine to get the angle out. So second sine, 2,000 divided by 10,560 is about 10.9 degrees. All right, I'm going to keep going. All right, flying squirrels in a tree 18 feet above the ground. Squirrel is up there. Angle of depression to the nut on the ground is 27. This is the ground, I guess. How far is the squirrel from the nut? So I'm going directly from nut to squirrel or squirrel to nut. So there goes my X. I'm going to use angle. Oh, let me label opposite, adjacent, hypotenuse. Opposite, hypotenuse. So I'm going to do sine here. Now, I know I tell you we do tangent a lot, but if you find yourself doing a few sines, but you know that you're doing it correctly, don't panic. Also, don't panic on solving this one. Get rid of your X so that you can get rid of that fraction. And then now we're going to divide by sine 27. I just taught this to my geometry kids, so I know I taught this to you 2 years ago, but sometimes we panic when it's not a super easy one. So I'm going to do 18 divided by sine 27. And I get 39.6 feet. Okay. All right, a pole casts a shadow that's 10 feet long. Such bad triangles. There we go. If the angle of elevation of the sun is 28, what's the height of the pole? Oh, we've got some breezy word problems here. Opposite, adjacent, hypotenuse. It's just a basic tangent. Don't make it harder than it is. X over 10. And this one's actually even easier because you just multiply by 10 on both sides. And I plug 10 tan 28 in the calculator. And I get 5.3. Okay. I've got one more kind of easy one, and I've got 2 tougher ones. So I want to make sure that I end with those. Find the angle of elevation of a duck in the pond to a hawk in the top of a tree at the pond's edge. Okay, let's draw my triangle. I've got a hawk in the top of the tree. Here's the tree, and then the duck is in the pond. Okay. The duck is 100 feet away from the base of the 32-foot tree. It says find the angle of elevation. Oh, that looks a little bit more complicated, but it was super easy once you labeled your triangle. Now I want to do opposite, adjacent, hypotenuse. I've got another just tangent problem. The only difference here is that we have to find the angle. So I'm going to do tan of theta equals 32 over 100. And so to find theta, I'm going to do second tan or inverse tan to find the angle. So second tangent, 32 divided by 100. 17.7 degrees. All right. All right, I hope I didn't move too fast through those, but I did try and pan out and pause. So if you need to look at any of the work or slow down, please feel free to. I wanted to make sure that we had time for these last two, and I put them next to each other because they're super similar. I did make these harder than I intend to make the test. So I have something about the pace and how long she's walking. That's going to be able to tell us her distance, okay? So it's saying Audrey's walking at a pace of 3 miles per hour, okay? I'm going to start by drawing a triangle. She's walking towards the Math Hall of Fame building. So she's walking towards this building. Here's Audrey. At one point, her angle of elevation to the top of the building is 11 degrees. So that's the farthest bit away. Then she walks closer to the building. I'm just going to call this Z as opposed to A. And her angle of elevation is 13.5. How tall is the building? So I need to know how tall the building is. I actually know this distance right here because of her pace and how long she's walking. I'm going to treat this like a conversion problem. I know not everybody likes to do it that way, but I'm going to think of it as 3 miles per 1 hour. Okay. And she's walking for 15 minutes. So I want to get it in terms of just miles. In 1 hour, there are 60 minutes. And she's walking for 15 minutes. The hours cancel, the minutes cancel, and I'm left with just miles. So whatever my answer is going to be that distance from A to Z. So 3 divided by 60 times 15 is 0.75. That might feel like a weird distance, but it's in terms of miles. So 3/4 of a mile, 0.75 of a mile is nothing crazy. Okay. I'm going to label this distance from Z to B as D as in distance, because I am going to need to use that. All right. I'm going to trace the triangles in different colors, and we're going to use tangent of each in order to solve. So I've got a pink triangle that I'm going to do over here. So D, X, and then 13.5. The way we've done all of these is it's always tangent just because of how it's set up. So I'm going to say tangent of 13.5 equals X over D. I'm going to simplify that in a second. Let me redraw the big triangle. I'm going to make that one blue. That's this big triangle here. Okay. So that is 11 degrees. I still don't know how tall the building is, but the base, the bottom, is not just D, it's 0.75 plus D. So when I do my tan function this time, it's going to be tan of 11 equals X over 0.75 plus D. Okay. Now, what's going on here, and we've done one of each at least, maybe 2 of an easier type, but if I can simplify the pink one all the way down and solve for one of the variables, great, but I have 2 variables in each one, so I can't do that. I'm going to take the pink one because it's the simpler one and make it equal to just one variable. So if I get rid of the D on the right-hand side and get D times tan of 13.5 equals X, then I can replace this with my X in my other equation. So I'm going to substitute out that X and I'm going to substitute in D times tan of 13.5. Everything else stays the same. Tan of 11 equals 0.75 plus D in the denominator, but instead of X as the numerator, we're going to write D tan 13.5. I just substituted that in. Now I have an equation with just D's in it, so I'm allowed to solve this. I'm going to fight to get D all by itself before I solve. If you want to make 13.5 or sorry, tan of 13.5 or tan of 11 a decimal at any point, you can do that. I'm just not going to. I am going to multiply by 0.75 plus D on both sides. And I am going to distribute that to the tan 11. So, oh, excuse me, 0.75 tan 11 plus D tan 11 equals D tan 13.5. Okay. Now I'm going to move the D tan 11 to the other side. So I'm going to minus it from both sides. We talked about this several times in class, but that does not make it D tan 1.5. You just have two separate pieces. So 0.75 tan 11 equals D tan 13.5 minus D tan 11. Let's factor a D out of both of these. So 0.75 tan 11 equals D times tan of 13.5 minus tan 11. And then let's divide by that tan of 13.5 minus tan 11 from both sides. Again, they're all going to be decimals, so if it makes you happier to put that in the calculator first, go for it. But I'm about to put this in my calculator now. So 0.75 tan, oh, gotta get a point. 0.75 tan 11 divided by, make sure your parentheses are good. I had to do something with mine. And then now for my denominator, I'm going to put it all in parentheses. So tan 13.5 and one set of parentheses minus tan 11. And now I have double parentheses. I think my little picture's in the way. Make sure your thing looks like mine and you get the same answer as me before you move on. It also makes sense that my distance here is 3.2 because again, I'm still in miles. I'm still in miles. Okay. Now I'm just going to plug that 3.2 in for this D. And I'm going to be able to do 3.2 tan of 13.5. And that's going to give me X. 3.2 tan 13.5. And this is my final answer. 0.77 equals X. 0.77 miles. It's kind of a weird way to measure a building, but that's okay. That's how tall the building is. Okay. I've got about 5 more minutes and I want to try and do the next one for you. It's the last problem on this sheet. Okay. You can go back at that one if you need to. This is super similar to this one that we just did. Okay. So I'm going to draw my big picture. Brianna is walking towards a building at a pace of 2.5 miles per hour. At some point, her angle of elevation is 18 degrees. And then after 20 minutes, her angle of elevation is 68. How tall is the building? So Brianna's here, then new Brianna is there. Here's the, I don't know, the ground of the building. Here's the top of the building. I don't know. Just trying to give it some letters. Now, what I do want to know is this distance right here. And just like we did on the last one, I'm going to do 2.5 miles per hour. I'm going to say 1 hour is 60 minutes. And we know that she went for 20 minutes. Minutes cancels, hours cancels. 2.5 divided by 60 times 3. Oops, not times 30. Times 20. I don't know. What am I'm tripping on something. Is 8.333. We're just going to round it to 0.83. And I'm going to label in between new Brianna and the ground of the building as little d. Okay. So now I'm going to redraw my triangles. The pink one's going to be this small one. X, D, 68. So I'm going to say tan of 68 equals X over D. And then the blue one's the bigger one. Sorry, my drawing's getting progressively worse. All right, 18 degrees. There's my right angle. The building is still X. I don't know how tall it is. And then 0.83 plus D. I will tell you that this is the second one like this that we've done. I would expect one pretty similar to this on your test. I won't do the conversion, but other than that, the process is really similar. I'm going to have to use my substitution. So let's multiply by D on both sides. So I get D tan 68 equals X. And then we're going to go substitute that in for this X. So tan 18 equals 0.83 plus D, and that is all underneath D tan 68. Just like last problem, let's multiply by the denominator on both sides. And let's distribute that tan 18 into everything. 0.83 tan 18 plus D tan 18 equals 0.83 plus D. I messed something up. Oh, no. I don't know why I did that. Sorry, this side should be the numerator, which is D tan 68. Oh, that was crazy for a second. All right, minus your D tan 18. And then we'll factor that D out of everything. As much as I want D tan 60 or 68 minus D tan 18 to be D tan 50, but it's not. Take that D out of both things. Divide tan 68 minus tan 18 from both sides. And then I'm just gonna throw that in the calculator. Right here. 0.83 tan 18 divided by, and I've got all my parentheses, tan 68 and my small parentheses, minus tan 18 and my small and my big. And I get 0.125. At this point, I go plug 0.125 in for my D, and I'm going to do that times tan 68 to figure out what X is. And I get 0.31 miles equals X. Okay. Okay. All right. I hope that you could kind of search and find for the problem that you needed help on. I promise that these are going to be like the test. Please, please, please look at this before coming to office hours and saying, I don't know how to do something. I would like you to watch this and I'd like you to ask me a question about it. That's what I'm going to tell you in office hours if that's what you do. Study your unit circle. Look at those problems that I showed you on that 4.7 homework that are fair game. Bring a calculator that you know how to use for all of this stuff. And yeah, we got our test on Monday. I'm going to post this right now. I hope you watch it. If you need help, come see me in office hours. You guys are going to do great, but make sure you're prepared. Bye.